You're listening to Accounted For, the Canadian podcast that explores the intangibles of every career. I'm your host, Daniel Lee. Hey everyone, welcome back to Accounted For. Today on the podcast we have another anonymous episode, and this is a quite technical one. This one we go deep into the realms of software engineering and what a software engineer does, specifically in the back-end realm of the things. And we also talk about the guest's life as a remote software engineer and what it really entails to work a 4-hour work week, how that was possible, and more about what the person does on a day-to-day basis. So I really hope you enjoy the detailed and somewhat technical conversation on software engineering. Hey everyone, welcome back to Accounted For. Today is another anonymous podcast series, and today we're going to be looking at the life of working remotely as a software engineer. And so, like always, all my anonymous guests do not reveal their names, and I will be calling them by the gender-neutral Korean name, Min. So hey Min, thanks for coming on the podcast.
Yeah, no problem, man.
Yeah, well, happy to have you here. And so we're going to be talking about the life of software engineers as well as working remotely, or I guess like semi-remotely, as I don't know how you would describe it. I call you remotely, but
I would say at this point it's basically remote, yeah.
Yeah. And I joke that you have the real 4-hour work week going on here, but I think you corrected me before we recorded that it's not the Tim Ferriss style of 4-hour work week. What's the difference?
Jokingly and kind of not jokingly, sometimes it is a literal 4-hour work week. Yeah, let's start with that.
All right, sounds good. And so to kind of give the backdrop, your title is a software engineer, and I asked you on the market, would you be a senior or whatever else, but you said it doesn't really matter on an objective basis, like given experience. Like how many years would you say, like would you be plus or minus 3 years of experience as a software engineer?
So I think people start referring to themselves as a software engineer once they've gotten at least a bachelor's degree. It's kind of taboo to say you are an engineer prior to having received your engineering degree. So usually when you're, let's say, an intern, your role would be software engineering intern, or you do software engineering at XYZ company, versus being an actual software engineer. It's just kind of semantics, but that's what happens.
So that it's actually like industry kind of jargon, or the kind of the industry, I guess, the street rules that people abide by.
A street rule is a good way to put it. I don't know if it's universal. It's just what I've noticed and what people have told me and how they think about it. But so following those rules, I would be an official software engineer for 3 years. But I would say that my actual experience with software engineering as a discipline is maybe 8 years. I've been doing it for ever since high school, so it's been a while for me.
Wow. And you said though the street rules have it as you need your bachelor's at least from engineering. What about people who do boot camps nowadays? Are they not considered software engineers? Or is there some controversy there?
They're literally and technically not engineers. But they may do the same work. But I think some people are pretty territorial about the word engineer, in that, I don't know, is it the same for public accountants or accountants? I don't know if there's anybody doing boot camps for accounting, but if they were, I feel like you would probably, maybe not you specifically, but some people would look down on it and say, hey, you're not actually an accountant.
Yeah, I think the way I would actually relate it is, so I don't know how familiar you are or how familiar some of the listeners might be, but on the technical premise back when instead of having a CPA, we actually had 3 different accounting bodies. We had the CA, CMA, and the CGA. The CA was considered to be the prestigious one. It was the one where you were truly, quote unquote, an accountant.
Right.
And then the rest were just things you could just kind of get without a bachelor's degree.
They combined them recently, right?
Yeah. And, I don't want to offend anyone here, but the rolling joke amongst the CAs was that, CGAs, you can get it from high school. Like a lot of immigrants got it because it was lowest barrier, and then CMA was the next easiest to get, and then the CA was the hardest to get, and that was what people prided it on. And nowadays, after the merger, though, people will still kind of ask, like, are you a CPA from a CGA background or a CMA background? Like they will dig into it to determine your quote unquote legitimacy, but that's slowly getting washed away. Whereas for, I guess, engineering, or software, it's becoming more like they're trying to lower the barriers more, I guess, as well, right?
Yeah, I think it's very similar.
I guess, yeah, you're right.
Because, a lot of people in the industry are actually not in engineering, right? They're not in, they didn't go through software engineering, but they may have gone through computer science, which, let's say we're talking about, the tiers like CGA, was it?
Yeah.
So like stuff like that, I would say, boot camps are at the bottom. And probably software engineering and computer science are about the same in that they will learn basically the same things. That's computer science and software engineering. They will learn approximately the same things. Computer science is probably a bit more theoretical. They probably take a bit more pure math courses, combinatorics, that stuff. While software engineering will have a bit more of the practical side with like industry standards and some, architecture courses or something. So in the end, you'll all be doing the same jobs, but there's I would say a bit of a stigma between some people as to where you came from. I don't personally subscribe to it that much because I don't really care about where your education was, just how well you can do your job.
In terms of the software engineering world, then I think the three common terms that I hear are, front end, back end, and full stack. And my understanding is that front end, it's basically the people that build whatever. If I was to look at an app like Facebook's app, let's say, it's all the stuff I can see. Everything I'm interacting with is front end, and back end are the people that actually have all the systems and stuff in place that ingest every data. And so like when I actually click something, it gives me whatever actually I clicked. And backend is someone that can do all of it combined. But I want to hear your perspective on how incorrect my understanding is.
I think there would have been a time where that was basically completely correct.
Also, I'm just outdated.
I wouldn't say that so much. It's just I feel like the lines are being a bit more blurred in that I'm not too familiar with a lot of the front end technologies these days, but I feel like there are less and less people that are just like purely a front end developer, and I think less people who are just purely front end, in that you can't just know how to make things pretty and stuff. You have to, at least to be a good engineer, you kind of have to understand the ramifications of whatever you're making in terms of the entire system. So I feel like maybe it just might be my limited perspective, but I feel like people are trying to branch out a bit more and understand, in a more bigger picture sense. But yes, I feel like that's a pretty good description, in that front end is usually what you can see, and then back end is a lot of the logic in whatever service you're interacting with. So, all the database management, any information you need to pull from somewhere else, or, there's many other things that happen. But I think that's a pretty good summary of what those roles are. Mm-hmm. Full stack is kind of to me, it's sort of a misnomer because it's very dependent on what the system is. A full stack engineer at a certain company versus another company might be completely different rules. So to have them be the same name is kind of useless, in my opinion.
Okay, can you expand on that part?
A full stack engineer basically means that you are touching every part of a system. And if you're doing, let's say, a website that tells you what traffic is like, versus a full stack engineer at Uber or Facebook, the roles would be completely different. I can't even imagine what a full stack engineer at Facebook would be or Uber in terms of, I don't have the information to know, because the system is so big that a full stack engineer could be doing this, this, and this, or another set of things. And, a smaller product, let's say, it just tells you if it's busy or not on the 401. That's not much work, in that the duties are, the set of things you could possibly be doing are much smaller. So then maybe you're a bit more front-end focused, or you're a bit more back-end focused, or something like that. I think the term is just way too wide for it to accurately describe anybody. It usually just means that either one, your current position is not extremely focused in terms of what you do, or two, you're not sure what your expertise is, so you call yourself a full stack engineer because you don't have not a passion, but a field of expertise that you're, what's the word, proficient in, I guess. A lot of people, I feel like, are like that, where they're not quite sure, and they can do everything, but they're not a master at a certain very specific thing.
So if an engineer were to specialize, is the realm of specialization at a broad scale front end or back end, or even if you're a back end engineer, is there a deeper set of specializations that you would say that you're proficient in? Like, is it categorized by languages, or how would you categorize it?
I think there definitely is. I'm trying to come up with more examples, and there definitely are. The first thing that pops into mind is, let's say, your company is built off of a really primitive, or not primitive, but like a really old language, which is the case actually for a lot of companies, where a lot of their core technologies are built by someone who's no longer there, in a language that is possibly outdated or no longer supported or even not understood by anybody anymore. Like, I think it might have been, I forget which language it is. I think it was like Fortran, that there are like a comically low number of people who even are able to understand or write in it at all. So those people are joked to have like tenure. You can't possibly fire this person anymore, just because if your company is actually reliant on something like this, you will not be able to find that other person, basically. I don't remember if it's actually Fortran, but it's something like that.
So I guess, like, sorry to interrupt, but it's like Latin in a sense. I'm guessing some people are probably like that, where they have languages that are no longer being taught, but they know it.
Yeah, and it's not that you can't learn them anymore; it's that nobody wants to. And especially if it's a core part of your company, then you have no choice but to have a specialist in that. But I think that's kind of a unique case and kind of rare. But you'll have people like database experts, people who are specializing in something like that. I don't know if that answers your question.
What would you say your specialization is then? How would you describe it?
I have no idea.
Oh, so you don't have one?
No.
Are you supposed to kind of eventually make your way into one? Is that the typical path of a software engineer, or do some actually just stay without specializing?
So I think there are two large branches of what happens in a software engineering career. Either one, you end up into management, or two, you continue developing forever, basically. And there's a plateau for that, I think, in terms of salary, and Mostly salary. In that, like, you can only make so much as a software engineer. And I think those are usually the two paths that people go down. If that makes sense.
Yeah, so it's either product management, right, mainly, or you just become like software engineer number 4 or something.
Yeah, something like that.
Yeah.
It might not be specifically product management. It could just be project management. You could manage other engineers. But yeah, I think it's either you end up in management or you just keep developing things.
And you brought up a very interesting point that I'd actually never considered about how, you know, if a full stack engineer was someone who would actually have, I guess, you know, blatantly speaking, like full ownership of the end-to-end process, like the end-to-end system, it might actually make sense why I see a lot of kind of job postings, or at least when I talk to some entrepreneur friends, where they talk about, you know, oh, I'm looking for a full stack developer. It's so hard to find a full stack developer, but the need to kind of find those kinds of people earlier in like these smaller companies where the system could actually be smaller, and why maybe there might not be that many full stack engineers in large system companies like an Uber or Facebook.
So the thing, okay, I think a full stack engineer is a superset of all the other types. So let's say front and back end are the only other types, but those would be subcategories in full stack, in that you are just narrowing the specialty. In that, if someone is a full stack engineer at a company, it does not necessarily imply that they are working on everything at that company. Do you know what I mean? So that's what it brings, or it goes back to my point before, where telling me that you're a full stack engineer at a certain company does not tell me anything, basically, because it could mean any number of things. While, you know, telling me you're a back-end engineer kind of narrows it a little bit, but we're still going to have to ask some more questions to understand what you do. So I'm not a huge fan of the term full stack engineer anyways. It doesn't really help anybody.
And so then in like engineering lingo, like how do you know, or how do you determine whether someone's a good engineer or a bad engineer?
If you could answer that question, I think you could make a lot of money. The interviewing process for engineers is highly documented and extremely difficult. I think it's probably one of the hardest problems you could solve. Yeah, I know the big companies have constantly, well, not just the big companies, all companies have constantly iterated on how to find a good engineer, right? They used to do brain teasers, riddles all the time. I think at one point, one of my friends was being interviewed, I think it was Microsoft, and the question was, let's see if I remember it. You're on a boat in the middle of a relatively still water lake, and there's a 5-pound rock next to you, and you throw it into the river, or into the lake. Does the water level rise, stay the same, or fall? Do you have an answer?
No, I'm not going to try.
Okay. Well...
just a caveat. Also, I guess the listeners might find this fun too, but I've had so many of those kinds of questions from all my consulting interviews.
That's funny.
And even all my investing interviews, I get so many of those questions. I hate it. Like, it makes me sometimes, like, it angers me sometimes, where it's like, how is this supposed to assess my proficiency in picking stocks?
Yeah, so I think it's one of the, it's one of the schools of thought, right? In that I can't, short of literally hiring this person, I can't realistically tell how they're going to perform in this job over a long period of time.
Right.
So one train of thought is, okay, I'm going to get down to fundamentals. Are they able to problem solve given limited criteria? Are they able to think outside box, critical thinking, that kind of stuff? Which, to a certain degree, I agree with. You should evaluate that. But perhaps not to the level of abstract riddles and stuff. But, I mean, I understand why they did it. Yeah. And I think most companies have moved pretty far away from that now. Like so far, in fact, that now it's basically a competition when you're doing interviews, in that some companies use sites like HackerRank, which there's automated scoring on certain problems. So they'll give you a problem set of maybe 5 problems. There's a fixed input that is expecting a fixed output from your solution, and they've got maybe like 10 test cases that are available to you. You can test your program while you do it, run it a few times, see if the output matches the input. Then you eventually submit it. And then there's hidden test cases, which you don't get to see. And then if your program has encapsulated all that the problem asks for, hopefully you get it all right. But it is a numerical score on how well you solve this problem. The issue is that it's a bit more practical than the riddles that we're talking about. But it is also a certain skill, in that you only have so much freedom in these questions, and it's a bit difficult to gauge someone's thinking when all you get to see is that number, right? Sorry, it's a bit of I'm not sure where I was going with this, but it's a tangent. So I think usually they're using that right now as a precursor to phone and Skype interviews, or just phone interviews at this point. So there's that, and then a phone interview, and then they do face-to-face interviews. So depending how large your company is, people will go through maybe 5 to 8 maybe rounds of interviewing. And depends on the company, but there's many criteria that they look for, and many different people that have eyes on candidates. And I think it's a constantly evolving problem. And they're constantly trying to find better ways of evaluating people. And yeah, no, it's I've thought about it a lot, but I obviously haven't come up with anything conclusive either.
And so you've interviewed, you've hired engineers,
yeah.
And so what's that process like for you? Like, are you evaluating their personality as you're talking to them, or are you throwing, is it like the brain teasers one where you're throwing them a question and you try to just get them to tell you what the thought process is as they're trying to answer the question? What are you evaluating now?
Yeah, so I would say between those two sort of extremes, I'm trying to incorporate what I believe to be the good parts of both of them. So one side is, one side of the spectrum is extremely practical, and then the other side is, well, I wouldn't say it's impractical, it's more ethereal, right? It's not something you can definitively say, it's just feeling you get from someone, right? So I try to give practical questions that require some thought outside of the muscle memory of how do I solve this type of problem. So without going into technical aspects, but a lot of these problems that companies give to people are the competition problems. So there are these coding competitions that are structured the way I mentioned, where there's certain inputs which require certain outputs. They could be numbers, strings, whatever. Can
you give like a more concrete example? Is there one
sure.
particular that pops to your mind?
I mean, there's thousands of them, but I can come up with an example. Yeah,
sure.
So let's say the input is a 10 by 10 square of characters, where a character can be an empty space, can be an X, or a number. So this represents a certain maze where you have to start from point A, get to point B. Your problem needs to figure out the maximum score you can get traveling from point A to point B, given you're allowed to move right and down, left, up, whatever. So that would be, some problem that you would have to solve.
And so they're solving it by, I guess, writing code and creating a program that'll calculate that. to give you an answer which should spit out a number which is supposed to be the fastest way.
Yeah, or whatever it's asking for, or the highest score they can get, or something like that.
Right.
So that is a certain type of problem. There are many types of problems. But yeah, they would have to come up with, well, first they need to analyze the problem, understand what it's asking for. Then they need to come up with a certain way to do it. Then eventually they have to decide on what they think the optimal solution is, and then start coding. Or, depending on if it's like an in-person interview, then a very common way of answering these questions is that they start off with the most mundane solution, which requires absolutely no thought and has terrible complexity and takes forever, takes crap ton of memory, and then they improve that solution iteratively. And I believe this is a very popularized way of answering questions. It's in a book called Cracking the Coding Interview. It's, I don't know if it's like, I wouldn't call it an industry standard. It's just what a lot of people do, I guess. But yeah, that's one example of a problem. So going back to what I look for, given a sort of problem similar to that, you have to be constantly looking for, well, let's see. So I think the really important thing that I look for, that I think a lot of people overlook, is communication. So I always ask them to talk through what they're thinking, especially when they're silent. Because as an interviewer, it's in their best interest, or interviewee, it's in their best interest to give me as much information as possible about them, right? So if you're just sitting there silently thinking about a problem, you might get it right, but I'm not going to understand how you got there. Are you able to, let's say, if we're working in a team, are you able to communicate your thoughts properly to other teammates? You're not the only one that, is going to be working on a certain problem. So I always ask them to talk through things. And so then there's, this verbal communication. Are they able to get their ideas across well? And then obviously you're looking for, are their ideas correct? Are they going down the right path? And, you look for things like, do they start coding without having fully thought through their solution? Are they just thinking along as they go? Or have they crafted a full solution in their head and then are ready to code? Or do they, they just fumble through it and continue to change their code over and over? Yeah, I don't know. Are we still talking about what I look for?
Yeah. Well, I guess in a sense of, I'm just curious on how you would evaluate where someone is good, is a good software engineer.
Yeah. No, it's a hard problem, and I could not confidently say that I could pick out a good versus a bad one. I think that you can be competent, but I think you could be a bad engineer and competent, in that there's so many facets that would make someone not a good software engineer for a certain company. So, some people are too attached to their code, in that they will fight and kick and scream when you try and change their code or suggest that they change it, which is almost like impossible to detect in an interview. How would I ever know this? They could be like extremely intelligent and know all these algorithms, know how to solve all these problems, but if they can't work well with your team, then they're a bad engineer. But I don't think anybody's found a way to interview that yet. Like I think there's way too many things to have to test.
Would you say though, then, kind of, if they had to go through 10 problems, getting at least like the best answer in the 10 is kind of table stakes, and after that it's kind of looking at the soft qualities?
Yeah, that's a good way to put it. I think yeah, the minimum requirement is that you're able to answer the problems that are given to you usually.
And that's the measure, would you say, of competence in that aspect?
Yeah, I guess it would be like fundamental competence in computer science.
And so for someone like me, if I were to hire an engineer and I have no engineering background, how would I evaluate?
I have no idea.
Wow, okay.
Yeah, I think that would be a very difficult problem.
Yeah, so
for you.
I'd probably need to get a friend who's a good engineer to come and help me out.
So the problem with that is that how do you know your friend is a good engineer?
That's true.
Well, you don't know if I am a good one. Maybe I'm bad. Who knows?
Yeah, it's true. Like I've assumed that you were a good engineer.
Oh, thank you.
Yeah,
I appreciate that.
So then, at least in the world that I'm from, like the quote unquote business world, people like to evaluate whether someone is competent or not based on the firms they work at, right? The white collar firms with consulting firm, accounting firm, finance firm. If it's a big enough name, they believe that you've jumped enough hurdles where they test for basic competence from your grades to these brain teasers to sucking a lot of dick sometimes to it honestly, I think it's just raw work ethic and just what I consider like at least just general, maybe like above average intelligence to have some kind of competence threshold. Right. Is that a good way to judge software engineers too? Because I don't think that's a particularly great way to judge business grads. But I'm just curious about the stigma in the industry where it's like, oh, if you were an engineer in Silicon Valley, are you considered to be of a certain caliber compared to someone who wasn't?
I think I'm pretty disconnected with the general consensus on that. But given what I know, that it is very difficult. Well, okay, one, it is very difficult to hire good engineers. And as a result of that, it can be assumed that it is very difficult to know a good engineer off the bat. Which means, three, all companies have bad engineers. And going back to, then can we use a person's employment history as a bar for how good they are? I would say no, because anybody can be a bad engineer at any company. So I would say that it has almost no correlation.
Out of all the engineers you worked with, what percentage would you say you consider to be actually good engineers?
I think a good amount of them. If I had to put a number, I mean, humans are notoriously bad at quantifying things, but I don't know, 70% maybe.
Okay. Do you find that that's a result of the companies you worked at, where they might have had a more rigorous process for selecting?
I don't think so. Actually, I'm not sure what I would attribute it to. It might just be dumb luck.
Because I'm wondering, as we talked about, where there is this trend with the lowered barrier for software engineering jobs, not necessarily software engineers, and a lot of people are transitioning out of other careers to go to a boot camp or find some other method of learning, even self-teaching, to become a software engineer for a technology-based company. Have you kind of seen this kind of influx? Like, what kind of trends have you kind of actually witnessed? Because I'm seeing it from someone outside, where I see it as people from the business realm, like business grads, moving in, and I read about it. But I'm just curious on what you've actually seen in terms of maybe an applicant influx or the kind of people that are now interviewing for these kind of software jobs.
Yeah, I think it's actually, for a software engineer, I don't think it's easy to get a good gauge of the entire market as a single software engineer, right? Unless you've worked at hundreds of companies over the past several years somehow. So from my experience, we as a company seek out candidates from certain schools. So it's not that the influx, or there's been a weird influx of applicants, which I feel like there may have been, but I'm not the one that filters out people who are applying through other means. So let's say they find the job posting at, I don't know, monster.ca or something. I don't know if we're on that, but if they do go through that and let's say, they're bootcamp developer, then I wouldn't know because I think someone else filters that before I get there. So I actually don't know if I have a good perspective on that.
What's the reason for the bias on the school? Is it the belief just on the technical competence that they would get graduating from a program?
No, I think it's just easy because there are job fairs. Yeah, so you have you have massive access to a bunch of new graduates, and then you interview them. So.
Got it. And I want to now kind of pivot into what you actually do as a software engineer, because I go to a coffee shop or I look at anyone who seems like an engineer, and you can kind of tell the screen's black and there's a lot of colored letters that they're writing, and I have no idea what they're typing, but the WeWorks tend to be filled with them. What do you do? Like, I don't know how else to really question it, but
okay.
How would you explain it to someone like me?
Yeah. Give me a minute as I organize my thoughts on this.
Yeah, I'll ramble on, but I'll also kind of give you a portrayal of my initial kind of assumption too. To maybe that'll also help. Where I think the closest way that I could maybe do some kind of analogy or kind of comparison is, so I work with Excel. I don't know if people still use Excel these days, but I used to do a lot of financial modeling, and the closest thing I got to any form of code was Visual Basic, like VBA, and I used that very rarely, but still I would create a model. I'd put in a lot of formulas that's supposed to give me this kind of output given these kind of inputs, and I have this sole focus of what I'm trying to achieve with this model. Like, I wanted to ingest X many thousands of points of data and pump out X many thousands of points in different categorizations, and then compute some values that I want out and create some kind of beautiful dashboard. Like, that's kind of the extent of quote unquote a system I would create. And my higher level belief was, I guess software engineering is kind of like that, where you just, instead of me typing in if statements and all that and doing like offset like formulas, you're just doing it on this black notepad and you put in all the commands and it solves a problem in that manner. So that was kind of my higher level overview. But yeah, I'd like your perspective on how you would explain what you or like a typical software engineer would do.
Okay. So I think this is a difficult question to answer generally.
Yeah, I bet.
I think you need to break it down in some fashion. And the first way that I can come up with is it depends on the stage of the company and the stage of the product or service that you're working on. So let's say we're at the beginning of the life cycle of a new product that you are a software engineer for. You need to be going through like functional requirements, use cases, like usage studies, that kind of stuff. You need to figure out what your product and what your software is going to do. What are the inputs? What are the outputs?
And none of that is coding. We're not at the black screen.
No, that would be no code yet. Yeah, we haven't decided anything yet. No technologies, no anything. Then, these things aren't even always set in stone because functional requirements change. The product changes, the needs change. So all this is up for debate in the future as well. But eventually you've got a good enough picture of what you're doing. Like this is really early stage, right? So you don't even have anything yet. Then eventually you'll start coding, and then this is I guess a different stage in the life cycle where now you're in like constant iteration and development of the product until you're trying to get to a MVP. was actually going to talk about like the distribution of companies in certain stages, but I actually have no idea how many are in certain stages, right? So when you're in, let's say you're doing. So I'm kind of glossing over the entire software, like the coding parts, because obviously during that initial stage you're doing a lot of coding. But we'll get back to that. Let's say you've got your MVP now.
So like the MVP, like for example, let's say it's like an app.
Yeah, sure. It's some app that does something, right? And it's on the market now. People are using it. Now you're getting feedback, and again, you're still coding all along this whole time. We'll get back to what actually that is in the future, but now you're taking in user feedback. I don't know, maybe investor feedback. Management still has some things they want to do, whatever. You have to deal with all that stuff. Still coding. Now, let's say you're a pretty mature company now. It's been a decade or whatever.
Sorry, can I interrupt you quickly there? You mentioned that you'd be picking technologies.
Yes.
What does that mean?
Okay. What was the app that... Oh, actually, you didn't give me an app example right now. Okay,
no.
So let's...
I'll let you pick one.
Okay. Let's say... Actually, it doesn't really matter. Let's say some general app. When I talk about picking technologies, it means could be a language that you can code in. Could be your cloud provider like AWS, Google Cloud, and stuff. It's just all the things that you require in order to make your product and to run that product. So it could be any number of things. It depends on what the product is. It could be like a provider for map data, or a certain front-end library that allows your buttons to look like clouds or something. That's a technology. That's just a term for it. I never actually took in that that people might not know what that means, but
yeah. Kind of. I was thinking, is this a really dumb question? But I also felt like, because when people say technology, I assume like microchips.
Okay,
and that for me is technology. But in I think this developing world where everything seems to be in the digital age, I was curious. What?
Okay. Yeah.
What technologies meant?
Yeah, in software, a technology is basically just a bunch of software. It could be anything. It could be like a library that allows you to read text from an image. So that's called like OCR, optical character recognition. So there would be a library out there that you can use that, you feed it an image and then it'll spit out the characters that are in that image for you. So that could be something.
And that's a service that you'd pay someone for?
There's open source ones, but you can pay for that stuff. And then that would be part of your design decision. Like, are we going to pay for this? Are we going to use open source? Do we need optical character recognition? Like that kind of stuff.
Got it. Okay, so... Okay, now we're back on track. So now you have the MVP, you're iterating, mm-hmm. and then what happens?
So let's say, you're a mature company now, and that after that phase, you've gotten to relatively stable point where your product is like, it's fundamentally not changing that much.
Is this the kind of point you'd say like where you're currently at right now? In terms of the type of work you're doing in like a phase?
Me specifically or the company?
You specifically, but is that different from the company?
Yeah, I think it can be because, companies don't have, or not all companies have one single product or service.
Right.
I am working on multiple things.
Got it.
So I've got one thing in a very early stage and I am maintaining several other things as well.
Okay.
So once you're in the mature phase, it's not that you're not developing new features and stuff, because I think to be a successful company, you eventually need to do that again. Like, you can't just rest on your laurels and assume that whatever you've done is good enough for forever, unless your company's trying to, plateau and coast, which I think is actually fine, in that not all companies need to balloon and make $1 billion, right? But yeah, no, you're always looking for new opportunities, but that might not be specifically what every software engineer does. So I think, that's an okay generalization, but we could dive into what exactly coding is if you want as well.
Yeah, that'd be pretty cool.
Okay. I've never heard it described as cool, but all right, let's do it.
It's a new world for me.
All right. Yeah. No, that's good. It's not new for me. So how do we even talk about this?
Yeah. So I guess one way is like so there's multiple things that I'm very curious about. Is like, so one particular aspect is the fact that you have multiple software engineers working on a product. I find that very sometimes perplexing or sometimes hard to grasp, where because I've had times where, back to my financial model analogy, you usually have one person build a financial model.
Yeah.
And when you hand it off to someone else to work on that model, it kind of goes to shit, because that person has to learn the way that you've done all the formulas, and then they either follow your sequencing or they just do it them completely differently themselves, and then they hand it back to you.
Yeah.
And then you have no idea what happened either.
Yeah.
So there's issues there. So most of the times financial models are just usually built by one person, and then I think Excel's basic enough that you can still try to work around and have like different sheets, have like different addition points, and then try to connect it. But for a very complex, product where you have quote unquote armies of engineers, like,
yeah,
I'm curious on that. Yeah, how does that work? Do you just say, I'm gonna work on making a button, and then you work on something else and hope it all links up?
Ideally, you have everybody on the same page in terms of workflow and documentation, in that there should be, I think, I don't know if this is true in general, but I was taught back when I first started, like in the beginning of high school and middle school, that eventually you should be writing 2 lines of documentation for every 1 line of code that you write. It's not really a hard and fast rule, but it's you get the idea, right? Like, there should be more documentation than there is code.
Oh, so you're actually so that, I guess that's the way like you actually communicate in I guess like asynchronously, in a sense, where you
Yes.
write a code and then you've documented down, you're communicating to other people that this is what this line is supposed to be, your thought process.
Yeah, I mean, technically it's not like nobody's writing that per line, but at some point you will have to not modularize, but you have to, at some resolution, let's say, each file or something will have documentation associated to, like, what does this do? What was the inspiration behind it? What's the point? How does it do it? What are the inputs or the outputs? Who wrote this? When did they write this? How do I contact them? That kind of stuff. But there's many different ways and accepted practices for how to manage a code base, because that's the entire problem, right? You've got hundreds, maybe thousands of people working on something pretty complex, but if it's done properly, then you could conceivably build something without having ever met any of the other people. So it's really it's not an easy problem either, because a lot of people are not very meticulous with documentation. Sometimes you'll come across code that has literally no documentation, and it's written in a way that, it's still English. If English were a coding language, it's still English, but it's, it's different slang. Like, the dialect is a bit different. They say this a certain way while you would say it a certain way. And I'm talking like that's almost literal, in that, in you said you use like Visual Basic for Excel sheets, right? Like, sometimes you have variable names, right? So you set something to a certain value, and then you modify it later for something, or use it for something. Let's say I name a variable number _ occurrences. That makes a lot of sense, right? Like, you can probably guess at what it's for and then what it's used for. Someone else writing it might name it X, which is terrible practice, but it's done sometimes. Some people do it. And then you look at some code and all their variables are A, AB, AAA, AC, and you're like, what the hell is this? So there are a lot of small problems like that make it difficult to collaborate, but that's also something you would look for in a good engineer, in that when they're coding, are their variable names, understandable? When they're writing, is it legible code? Like, can I understand what this is doing without having to decipher it and go through it in my head?
Oh. So you're actually, it's literally commanding the computer to do something in a very simplified manner. Like if I were to say in a very simplified manner, it's like you're literally writing something down.
You're writing commands. Yeah. But collaboration it's a highly, I guess I was gonna say it's highly researched, but it's not. I wouldn't say. I don't know if anybody's actually spending their life researching this, but it is highly contentious and debated.
Yeah, and this might be a pretty cool segue into the 4-hour work week. And how you work remotely. I guess it kind of makes sense that you can.
So alongside documentation, there's actually, I think, the biggest and most important thing on how to collaborate is it's called source or version control. So I don't know if you've ever come across this, but let's say you're working in an Excel spreadsheet, right? Once you close it and you open it again, you can no longer Control Z, right? Go back and see what you were doing before. And especially if you were to give it to someone else, now they actually have no idea how you came to this conclusion, right? They have to figure it all out again. So, one thing that is done in every software company, which I think should be adopted by every industry basically, is version control. So there exists somewhere, I guess it depends on the type of version control, but basically the idea is that every change you make to the software is documented. So every time someone wants to make a change or add something or delete something, they have to attach to it a commit message. So making something is done in terms of a commit. So you make a change in your own little copy of the software, and then you push it off somewhere to the main copy of the code, and along with it, your changes, there will be some message that says, hey, I'm changing this because of this, and I did it this way or whatever, and then someone will accept it, and then it'll get merged into the main source code. So what happens then is, let's say we hire someone new, and they have to start working on the same software I'm working on. They make a copy of the original, which is somewhere. And along with it, they don't just get the code. That would be like the Excel spreadsheet, right? They also get every change that has ever been made on that source code, all the way back to when there was literally nothing, and someone put in the first file, or someone wrote the first readme dot text that says hi, or something like that. So they could recreate every change that has ever happened on the software, and then they can add on to that.
So that's all in just one typepad document.
It's not a document. It's a list of changes basically. So let's say if we go back to the Excel spreadsheet example, right? One commit or change could be, I deleted this cell. It can be as small as that. So if you replayed all of those changes from 0, it would be able to get you to exactly where you are now. So the power of this is that not only now do we have an exact record of everything that has happened, we can now pick and choose where we work from. You could, let's say after a certain point, we actually fucked up, and all of this stuff is useless. You can throw it all away, or you can start from a bit earlier, only take that part, and then move on from there. So there's this is one thing that, software engineers got right, is that there's meticulous record of everything that has been done if you've done this properly as a company, which I think most have at this point. It's basically standard. So I think that should be something that is adopted wherever possible in other industries for something as important to them as software is to a software company.
Yeah, you mentioned it. We ended up having to institute something like that too when we were passing around Excel models. So yeah, eventually we had like Excel model dot version 10, and then we'd parentheses the name of the person who used it, and then it's just eventually it goes like that down to like version 68, and then parentheses Lee was the last one who created it.
This takes it to the next level and has now been standardized. So it's one of the things I admire the most about the discipline.
All right. So then maybe now moving over from the technical talk to the kind of like working life you have right now, which I think would be the envy of so many. I guess the easiest way to ask the question would be, how did it happen? How did you manage to just work remotely and work 4 hours a week? Are you just that good?
I think most of it was dumb luck. It's not a common situation. I think there are many factors that came into play for it to happen. Like, I didn't know this was what it would be coming into the job. But it's also a choice that I made. And that I consciously and unconsciously moved towards. So when I first started, I knew that I wanted to separate my life outside of work and at work, in that I was not planning on making any relationships at work either. So nothing outside of professional. And
like relationships as in like not even friends at work?
No, yeah. I have no friends at work.
Why did you want to create that separation?
It was not really a hard, fast rule. Like, if I met somebody that I think was interesting and, would provide a lot of value to my life, and I thought they were cool, then I would be open to it. But I think that at the time I had enough of that in my network that I was not looking for anymore. I realized that, especially after university, that I was juggling too many relationships and it was taking too much energy. And they were not all providing value, as it were. So I had a lot of things that I wanted to work on outside of work, and I think the inspiration for this was when I was going to class at university. Whenever I had a class with people that I liked, that were friends, I remembered that I would have to look back at what happened in that lecture a lot. Just because you end up talking or looking at stuff or whatever, just hanging out, right? And that has happened at work before when I was, doing internships and stuff. And I thought about how much time that actually was wasted at work when I needed to get certain things done. So instead, because my priorities were not work specifically in my life at the time, I was trying to be as efficient as I was, or as I could be, with my time at work. And in accordance with that, I would then not spend any time trying to make friends at work either. Taking that to the extreme, eventually I realized that I was on projects that nobody else was on at the office. So they were, within several months, I realized that I could go in for a day and be working and not talk to a single person.
Do you think they is your belief or assumption that they pushed you onto projects that nobody else in the office was on because no one really knew you?
No. I think that was just happenstance, and I think I may have pushed for certain projects as well. I mean, at first I was working on things that required me to work with other people in that office specifically, but eventually I was only working on projects that had other people who were working remotely, or people who were working in the offices in Asia or Europe or the West Coast.
And are these then other software engineers that you're collaborating with and doing the version sharing or version control stuff?
Correct. I mean, we are all doing that, but yes.
Gotcha. And sorry to deviate again, but so if you're all working on that one problem, are you guys just if it's like let's say it's a massive problem where it's like, oh, we want to create this whole new feature, then are you guys kind of divvying it up to say one person should work on this feature, one person should work on like one component, another component, and then you're hoping that when you mash it all together, it all flows?
Yes, exactly. So what you're describing, or rather, what you're describing is what happens when it's done properly, in that you can just put it all together and it works, right?
Oh, okay. If Agile works properly?
That is almost never the case. Yeah, exactly. That is almost never the case, right? I mean, even when you're building something on your own, the first time you run something, I can almost guarantee it's not going to work. It's either not going to compile, or it's going to run but it's going to do something wrong, or it's going to crash, or it's not going to end up with the right result. It's an iterative process, right? So the way that version control deals with this is that, well, the main problem is parallelism, right? So because it's one entity at some point, like the end result needs to be one piece of software. So what happens when two people are working on different things, but both need to get integrated into the main source? So that's the most basic problem, right? You've got two people working on the same piece of code simultaneously, and let's say they both actually need to change the same file. They need to change the exact same line, let's say. What happens is then, when you go to commit to push to the main repository of code, what happens is one of you is going to get to do it first. So let's say person A finishes first, and they get their code in, and there's no problem because nobody's made any changes yet to the main source, right? So that's fine. Then once person B finishes, they're like, hey, I'm done. I'm trying to push this new change there now. What they'll find is that the main source has changed. So what happens now is that they've diverged in their changes. They used to be at the exact same spot when they both took a copy, right? But now they both made changes. So the problem is now the second person needs to integrate the changes that the first person made and make that work. So at some point, the conflict needs to be resolved. So that happens all the time. And that's basically how the problem is resolved, is that you can never have two commits go in at the same time. It has to happen sequentially. And as a result, someone will always have to resolve the conflict and make sure all the tests pass before they commit their code. So that's basically how you're able to collaborate.
And which would probably also mean then, because you can only do one person at a time, that if you have three people in the team, the other two are probably waiting around for the first person to do their stuff, do the test and everything, and then only then afterwards you can probably do your stuff, right?
You'd think so. So that's only the case if your work is directly dependent on them finishing their work. So if divvied properly, you are able to finish multiple tasks that are independent of each other, or at least relatively independent. And then those can go in. So sometimes you can actually have two people commit basically back to back. But if their code doesn't touch each other's codes, then there's no conflict. Okay. So at that point, to avoid the problem that you're talking about, is more of a management problem than it is a software problem.
Got it. And so going back to you now, so then now you're on all these projects that people in Europe and Asia are on, and so then you realize that I don't have to go into the office anymore.
Yeah.
And so then eventually you just stop showing up, and no one's the wiser.
I wouldn't say no one's the wiser. People definitely know, but I also wouldn't say that I'm an outlier. I think this is also common. It's just maybe I've taken it to an extreme that other people haven't, but it's a common practice.
And I like to joke and make fun and say that you work 4 hours a week. How many hours do you actually work on average, would you say?
I mean, again, humans are not good at quantifying things.
Sure, right. But humor me.
The thing is, the nature of the work that I'm currently doing is that I'm dependent on external partner deadlines. So sometimes there's literally nothing to do on a certain project, right? Because we're waiting on them for feedback, and then you have to start making changes. So it really is hard to gauge, because sometimes I'll have 3 deadlines for 3 different companies in the same week, and then I'm working like 80 hours a week or something like that. Sometimes I have none, and then I've got internal projects that are long-term roadmaps that are like supposedly like multiple years timelines. So those are like hard to gauge, because you could work a little bit now or not at all, and then you're still moving towards your goal eventually. But like those don't have hard deadlines that need to be hit, so progress is more fluid, I guess. So yeah, no, I actually can't tell you, but I would, if I were to hazard, I guess, an educated guess, maybe 20 hours.
Would you say that's normal for software engineers, or are you more on an extreme outlier case from what you've seen from colleagues, friends?
Definitely not within like one standard deviation. Like I'm pretty far, I'd say.
Yeah, because my assumptions are typically, I think the average is still like around 40 to 50.
I think it's higher.
Oh, it's higher. Would you say that's dependent on the size of the company?
I think there's many factors. Some teams are, I think it's team dependent usually.
Oh, okay. Yeah, it's true. I had a friend at Facebook, and he was telling me how some teams, you don't do anything all week. Like you work.
Yeah.
You actually, like the work hours is like probably 10 or something. And then the crucial teams might actually be killing themselves.
Yeah, that's usually how it goes. Yeah.
I guess there's not that much difference between big and small in that aspect. Or do you think startups might require more because you're trying to create something, at least pre-MVP? Or
yeah, I would say you would be hard pressed to find times like what I'm doing for an early stage startup, just because they've got shit to do, right? So they have hard deadlines they need to hit, or else they're gonna run out of money.
Right. Whereas, as you said, like your company is relatively mature and there's a lot of maintenance stuff. Gotcha. And so then how do you prioritize like your projects and stuff? Is it, or I guess you already have deadlines, so that might be easier to prioritize. But when you're actually allocating hours, can you tell how long certain problems will take?
Yeah. I would say that the better engineer you are, the better you are at estimating how long something will take. But I think everybody is still bad at that. I don't know where I heard this or where I got this from, but when asked to estimate how long a certain engineering task will take, you try and imagine how long it'll take, multiply it by 2, and then add 3 days. That's some rule that I remember hearing, and I was like, yeah, that sounds about right.
Oh yeah.
Yeah, I think it's very easy to misjudge how long things will take, because, at least for me, usually it's not that you have to figure out how to do it. You know how to do all the steps that need to be done, and I think that's where the problem comes in, is that you're like, okay, I can do this, I know how to do this, I know how to do all of it. It should probably take me a day. But it turns out like it's not perfect. It's not, just because you know how to do all of it doesn't mean you can just one-shot everything. There will be things that come out that you don't even account for, which, that's life, right? But I think it's notoriously easy to get it wrong in software.
And so, in the idea of misjudgment, what do you find is a common engineering misnomer, or things your family or friends think of as a typical software engineer would do, or a day is like, but you have to kind of constantly correct them and say, no, I don't know why you have that assumption. That's not what I do.
I actually don't hear that many things.
Oh, you don't?
Yeah, no, I don't.
People just get it right all the time?
No. I think people usually don't talk about it, or at least the people that I hang out with don't really talk about software engineering.
Well, one thing that I heard about from one of my friends down in the valley, he was working in one of the big tech firms there. I'll just hide the name. He's telling me how it was very common for all the engineers to gather during lunchtimes or whenever in the fully stocked cafeterias and just do brain teaser problems. Apparently that's what they do. And it's they love doing it.
I will.
And he was like, "Yeah, man, that's the valley, and they either do that or Dungeons and Dragons."
I will not confirm nor deny whether or not that happens. Here, let me try and explain why that happens. I haven't really thought about this too much, but the first explanation that comes into mind for me is that when faced with a problem that you need to solve, or a feature you need to build, or a bug you need to fix, there's two things you need to do, basically. Number one is you need to formulate a mental model of exactly what the problem is, what needs to be done, and how you're going to do it. And once you're done that, that's 90% of the thinking, I'd say. Random number. But you get the idea. And then once you start actually coding, there's barely any decision making that needs to be done. The implementation is, I like to call it brainless. It's not, but it's pretty close compared to the first part. You need to put all that thought in prior.
Yeah.
And then you switch modes into implementing it. And then you have to think a bit when you write test cases, or you have to you run into a bug you didn't think of, right? And then you have to think again and solve that. But those are the two major modes that you exist in as an engineer. So the reason, in my opinion, why you'll find people playing ping pong or doing brain teaser problems is that they're not in the first mode anymore. So they're currently not, using all their processing power to solve a problem. Maybe they're actually compiling something needs to be built, and it takes 4 hours. What are you going to do?
You let it run on the side, and it takes 4 hours?
So there is a joke that, I think this is an XKCD comic as well, but it's like I don't remember what it actually was, but basically the software engineer is just not doing shit, and then the manager comes in and he's like, hey, shouldn't you be working? He's like, my code's compiling, and then the manager walks away and is like, okay, cool. So that is a misconception, but also not really a misconception.
So code compiling, what is that? You just...
tough explanation here. So we talked about before how code is just commands, right?
Yeah.
So when you write formulas for Visual Basic, right, sometimes it'll be like, this formula is incorrect, right? It doesn't make sense. Mm-hmm. You're missing an argument for this bracket, for this multiply function or whatever. Mm-hmm. Maybe not to that degree, and that is very obvious, in that you're missing like it's literally written wrong, right? Something like that could happen in code where it's not immediately visible. So
like you won't get a warning that this is
wrong. Right, like you can't really simulate your entire system and how it's going to run given all these extra parameters when it's actually going, right? You can only imagine how it's supposed to run given these commands. So in order to actually know if it's going to work, you have to compile the code that you've written as a software engineer in a certain language. So the machine doesn't understand this language because it's something that we made up so that we can do coding in an efficient way that makes sense to us. The computer only understands a certain type of language, which we'll call machine code. So that is something that humans don't inherently understand. It'll just be a bunch of ones and zeros and stuff.
Okay, so like you're typing in, let's say you're typing in Python, and so Python is code that we've created, but the computer can't read Python, so it has to somehow go through another process where there's like a compiling, and then that turns that into 0, 1.
So there are certain steps. There's a bunch of steps that you have to go through to get from, let's say, Python to a point where a computer knows what to do with your instructions. So all of that, let's say, some of it is part of the compilation process. So eventually you get to that point, and then you can run it, and then you'll see what happens. So depending on your system and how well your build system is, and how good your code is, and that could take a couple milliseconds, or it could take hours. Depends how big your system is or how complicated. So when someone says it took 2 hours for the code to compile, like, sure, I mean, I could believe that. Just depends on what the system is. So it is possible that let's say you've got certain tasks that need to be done sequentially, like waterfall style, right? Like you can't do B until you've done A. But A takes 4 hours to compile so that you can test it, see if it works. You can't really start on writing B yet. You could think about it, but to a certain degree, you can't really put all of your effort into working on that next thing yet. So sometimes you are technically blocked by having to finish certain things first. And sometimes this happens because you're blocked by other people. And then,
Gotcha. And that I can actually relate with that, the 2-step phase of the 90% being the planning phase, where it's true, like when I make a financial model, most of my time is spent on like a yellow pad, and I'm just drawing out how information should flow, and then I write down the formulas that I want to put in to make that information flow happen. But I find my constraints are limited by the formulas I know to put into an Excel. And I agree, like after that, the execution tends to be easy. You find bugs, and then you fix, and you iterate. The limitation on the formulas, is that a similar concept in coding as well? Where like for Excel, it's dependent on, like, do you know if statements? Do you know offsets? Do you know, index match? Like these kinds of formulas. But for coding, is it like that? Is it like a bunch of kind of set formulas that are foundational and fundamental that you learn, and you just continue to just use those?
Yeah. I think a majority of the logic, let's say, we'll call it logic. The logic that you write as a software engineer, like the commands you write, they will follow certain patterns which are taught in school, right? So these are like accepted ways of doing certain things. Just because, I don't know, they're either proven to work or it was some algorithm that someone came up with that does certain things, right? Then there's like practices, like best practices for doing certain things. That stuff applies across languages. So yes and no, in that like there are fundamental things that you should know. But when you need to write it in a different language because the company you just got hired to uses this language, then you need to learn that language. But you don't need to learn the fundamentals anymore because you should have that. So really, you only need to learn like the alphabet specifically if you were to correlate this to languages, you already know, what words mean generally. You understand, the world around you. You just need to understand how to communicate it a different way. So you need to learn sentence structure. You need to learn word order, like that kind of stuff, which is pretty easily picked up once you've already learned one language. Generally, it's not very hard to learn another one.
So I guess that's what makes boot camps possible for someone to learn coding in like 10 weeks.
I don't think you can really learn that, or you can say you're adept at coding in 10 weeks. Yeah. I think it takes a lot longer than that, but that's just my opinion, I guess.
Then how are these people getting jobs out of boot camps?
Because it's very hard to tell if someone's good or not.
There we go. We go back right full circle.
Yeah, I think I could, if you wanted, I could coach you to get a software engineering job in a few months, probably. At like a relatively good company.
How many hours of coding are we going to be doing a week?
I don't know, but I don't think it would take very long. Because the interview process is pretty exploitative, in my opinion. It's just because the problem's hard. Nobody solved it yet. You might not be able to get through a company that has like 8 rounds of questioning where they ask you a lot about like system architecture and your past projects and how you design all this stuff and why'd you make this decision over that decision. Let's say we have this system with this and this and this. How would you change it so that we can do, like, if they ask you more questions like that, then they would eventually find out that you're a fraud. But there are a lot of companies who don't have the luxury or the resources to be able to vet someone like that, right? So they rely on giving them what they perceive to be, relatively difficult problems or industry standard problems. And if they can solve that, then fuck it. Like, let's just assume that they can code well. So it's not a difficult system to game for certain companies.
All right, so you're going to get me a remote software job in 2 months. I got it. Excellent.
I mean, it would be possible, but they would probably figure it out eventually.
Yeah. But enticing. It's an enticing proposal. I'll consider it. I do believe that I should learn coding, though. It seems like it's like why I learned accounting. It's fundamental language of business.
I think there are certain things that should be known, and I don't think actually that many advanced topics or even intermediate topics are necessary. I think the most important thing, in my opinion, is to learn more about systems and how they're structured and how the internet works, basically.
Is there a book for that?
There are many books, yeah.
Is there one you like? Or that you...
Not off the top of my head, but I do have this written down somewhere. I'm sure I've read this a long time ago. But I think, I mean, you can learn this on the internet. That's the beauty of it, right? I think being someone who is, not working in software engineering, it is critical to know, all the different pieces that are required for a business that needs to operate in the digital era, right? Like, you need to know about cloud computing. Like, you need to know about databases. I don't know. You need to know about all that stuff. Like, without that, everything is just a black box to you, and then you've got to hire more people, I guess. You've got to just trust other people. They know what they're doing. They're not overcharging you for stuff you don't need. I mean, that's just a couple examples of why it would benefit you. But I think you don't necessarily need to learn how to code. I think it's better to know what's actually going on outside of code. Like what are these different parts and what do they do? Why do they need them? Which doesn't really require that you touch any code at all.
Oh, good point. Now it's just figuring out what parts they are. So there's cloud computing, data management.
Well, I mean, those are just a bunch of stuff.
Yeah.
I don't know. I'd have to think more about this just because it's like if I asked you what are core tenets of finance. Like, I feel like you could probably name a few, but it's like this so internal to you already, right? This is just how the world operates in my mind. I have to really think about it to come up with the things that you should know.
Good point. Yeah. Well, I think that might be actually a pretty good place to wrap it up for today.
All right.
All right. Thanks a lot for your time. I appreciate the chat and learned a lot today.
Yeah. Thank you.
All right. Thanks for sharing your story with myself and my audience. Talk to you later. All right. Thank you for listening to the podcast. I hope the story was inspiring to you. Hopefully it also helped you expand your perspectives. Hopefully it also made you question the default path that you might have been going on, or the default beliefs you might have had. And maybe now it'll make you even think about doing something about it, doing something different, maybe challenging yourself, being courageous. Who knows? But regardless, I'm really happy that you took some time out of your day to listen to this fantastic story with my guest. And if you would like to somehow, in some way, contribute and help support the podcast, and maybe even just be part of the community that I'm trying to build with the greater OMD Ventures platform, really think about being a stakeholder in the platform. And the quick way to do that is to go to my website, oldmandan.com, and go to the stakeholders page. I believe it's oldmandan.com/stakeholder. And the link is also down below. And that's how you can figure out how you can subscribe, follow to get more updates on the free content, but at the same time also donate by actually just buying me a coffee. That's just how I put it. And you can buy me a coffee a month, coffee a week, or coffee every day of the year. And think about it as the way that, if you wanted to chat with me, you might just bring me out for coffee and buy me a coffee. Or if you wanted to bring one of my guests out to chat, you might buy them a coffee. So just think of it as I'm the service that's doing that for you, so you can just pay me in coffees. Don't worry, everything will still be free. It would just really help if you would like to show your support this way, so that I can use the coffee money to buy myself actual coffees, and also to buy my guests actual coffees, and use the leftover money to actually grow the platform, as well as even keep it operationally alive as well, because all this isn't really free, and it does take a lot of time to build it as well as operate it and hopefully grow it further. So your support would be amazing if you would like to contribute. And so just check out the website, go to the stakeholders page, and read the different kind of benefits you might even get as a stakeholder. All right, thank you.